Good morning all. In the lecture series of field effect transistor, we will discuss another kind of field effect transistor, another kind of FET, that is MOSFET. So today we will discuss about MOSFET. The full form of MOSFET, it is metal oxide semiconductor field effect transistor. Okay. Next, depending upon the construction of MOSFET, there are two types of MOSFET. One, it is called as depletion type MOSFET. In short, it is called as DMOSFET. The another kind of MOSFET, it is enhancement type MOSFET. enhancement टाइप MOSFET को शॉर्ट में ई MOSFET कहते हैं. Now, as I have mentioned, in FET, either the electron or the hole will undergo the current conduction mechanism. So in depletion type MOSFET, if the electron undergo the current conduction mechanism, it is called as N-channel DMOSFET or N-channel depletion type MOSFET. If the hole undergo the current conduction mechanism, it is called as P-channel depletion type MOSFET, or it is P-channel DMOSFET. Similarly, in enhancement type also, in enhancement type, if electron undergo the current conduction mechanism, we call it is N-channel enhancement type MOSFET or N-channel E-MOSFET, or if the hole undergo the current conduction mechanism, we call it as P-channel enhancement type MOSFET. Okay. So in summary, I would like to classify the field effect transistor. So in summary, this FET, we have discussed the two types of FET. One, it is JFET, another is MOSFET, MOSFET, it is of two types. Depletion type MOSFET, in short it is called as DMOSFET, and another type, it is enhancement type MOSFET, or in short it is called as E-MOSFET. Again, depletion type MOSFET, it is of two type depending upon the charge carrier. If it is due to the electron, we call it as N-channel, and if the current conduction happened due to hole, it is called as P-channel. Similarly, E-MOSFET, it is also of two types, N-channel another one is P-channel. And JFET, It is also of two type. If the current conduction happen due to electron, it is called as n channel JFET, and if the current conduction happen due to hole, it is p channel JFET. So we will start our discussion. With depletion type MOSFET. So let's start with the construction of depletion type MOSFET. So for depletion type MOSFET, here I have shown you the construction. This first one, it is the construction of n channel. This first one, it is the construction of n channel D MOSFET. And this second one, it is the construction of or the device structure of p channel D MOSFET. So to understand the construction of depletion type MOSFET, first of all, we will consider the n channel MOSFET, and similarly we can explain the construction of p channel MOSFET. So in n channel MOSFET, it consists of 4 terminals. The first terminal, it is this drain terminal. The second terminal, it is this gate terminal. The third terminal, it is this source terminal, and the fourth terminal, it is this substrate terminal. Similarly, we can see in p channel MOSFET also, it consists of 4 terminals. This one is the drain terminal, this one is the gate terminal, this one is the source terminal, and last this one, it is the substrate terminal. Alright. This shaded region, it represents the metal contact. Okay. This is the end region. This is the end-op region. This is another end-op region. So let us consider this end-op region. This end-op region is connected to the drain terminal through this metallic contact. Similarly, the source terminal is connected to an end-op region through an ohmic contact. This middle layer, this middle end region, it is called as the channel region, and we can write it as n channel. So the gate terminal, it is remain insulated from this n channel due to the presence of this SiO2 layer. This dotted portion, it is the SiO2 layer. SiO2 is very good insulating layer. So this SiO2 layer as an insulating layer, it is used to insulate gate terminal from the channel. Similarly, we can explain the construction of the p channel MOSFET. In p channel MOSFET, this is the p-dop region. This one is the p-dop region. So p-dop region is connected to the drain terminal through an ohmic contact. This is another p-dop region. It is connected to a source terminal through a metallic contact. This is the gate terminal, and this is the p channel. And this dotted, as I have already mentioned, this is the SiO2 layer. So the gate terminal is remain insulated from this P channel due to the presence of this insulating layer of SiO2. Alright, so this covers the construction of depletion type MOSFET. So a depletion type MOSFET consists of 4 terminal. So a depletion type MOSFET is consists of 4 terminal: drain, gate, source and the substrate terminal. Drain is connected to n-doped region through an ohmic contact in case of n-channel MOSFET. In case of n-channel MOSFET, this source is connected to n-doped region through a metallic contact. Gate terminal is remain insulated from this n-channel due to the presence of this SiO2 layer. And to construct the n-channel depletion type MOSFET, we use p-type substrate. We use the substrate as of p-type semiconductor material. In case of p-channel MOSFET, it consists of 4 terminal: drain, gate, source and the substrate. Drain is connected to the p-doped region through this ohmic contact. Source is connected to the p-doped region through this ohmic contact, and gate, it is remain insulated from this p channel due to the presence of the SiO2 layer. And to construct p-channel depletion type MOSFET, we use substrate as of n-type semiconductor material. So look at this. Here I have mentioned some point related to the construction of n-channel depletion type MOSFET. Once you understand the construction of n-channel depletion type MOSFET, in your own words you can explain the construction of p-channel depletion type MOSFET. So the first point here I have mentioned, it consists of 4 terminal: drain, gate, source and the substrate. The second point you can mention, drain terminal is connected to the n-doped region through the metallic contact. Source terminal is connected to the n-doped region through a metallic contact, and gate terminal, it is not connected or it is remain insulated from the channel due to the presence of the SiO2 layer. Next, to construct the n-channel depletion type MOSFET, we use p-type semiconductor material as the substrate, and the presence of SiO2 layer, the presence of the insulating layer of SiO2, it offers very high input impedance to the device. So in the similar manner, you can explain the construction of p-channel MOSFET. The p-channel MOSFET, it also consists of the 4 terminal: drain, gate, source and the substrate. In case of p-channel MOSFET, drain terminal is connected to the p-doped region through an metallic contact. Source terminal is connected to a p-doped region through a metallic contact, and gate terminal, it is remain insulated or not connected from the p region from the p channel. And to construct a p-channel depletion type MOSFET, we use n-type semiconductor material as the substrate, and the presence of the SiO2 layer, it offers high input impedance to the device. So in this manner we can explain the construction of n-channel MOSFET and the construction of depletion type MOSFET. Okay, we will discuss the symbol of depletion type MOSFET. So look at here I have drawn the symbol of n-channel depletion type MOSFET and the symbol of p-channel depletion type MOSFET. n-channel depletion type MOSFET में ये 4 टर्मिनल्स, ये हमारा ड्रेन, ये हमारा सोर्स, ये हमारा गेट और ये हमारा सबस्ट्रेट. ठीक है. n चैनल के केस में सबस्ट्रेट में जो एरो का मार्क होता है वो टुवर्ड्स दिस साइड, टुवर्ड्स दिस रिवर्स साइड, right? This is the another symbol of n-channel depletion type MOSFET. This is the drain terminal, this is the gate terminal, and this is the source terminal. And in this case, the substrate and the source are sorted to each other. The substrate and the source are connected to each other. So generally, sorry. So in this case, the substrate and source are connected to each other. In advanced electronics, in VLSI design, you will learn by applying the potential at the substrate terminal, the threshold voltage of the transistors can be changed. The threshold voltage of the transistors can be modulated. So in this case, substrate, it is not connected to the source. So you can apply some different potentials, maybe some positive potential or negative potential to the substrate, and correspondingly you can modulate the threshold voltage of the device. In this case, source and the substrate are connected to each other. So when the source it is connected to some other potential, the threshold voltage of the depletion type MOSFET can be changed, and this effect it is called as the body bias effect. So in this case, body bias effect is present, and in this case, since the substrate it is connected to the source, so in this case body bias effect is not present. Next, similarly for the P channel MOSFET, in P channel depletion type MOSFET, this is the drain terminal, this one is the gate terminal, and this one is the source terminal, and this is the substrate terminal. And in this case, the arrow in the substrate terminal, it is in the forward direction. This is the another symbol of P channel depletion type MOSFET. This is the drain terminal, this is the gate terminal, this is the source terminal, and in this case the substrate and the source are connected to each other. So since in this case the substrate and source are not connected to each other, you can apply some potential across the substrate terminal. So we can say in this configuration, body bias effect is present. But in this case, the substrate and the source are connected to each other, and hence in this case body bias effect is not present. Next we will discuss the working principle of depletion type MOSFET. To understand the working principle of depletion type MOSFET, here I have taken the example of N channel depletion type MOSFET. This is the drain terminal, this is the gate terminal, and this is the source terminal, and this one is the substrate terminal. So in case 1, this source terminal and the substrate terminal are connected to each other. Okay, this substrate terminal of the D MOSFET and the source terminal of the D MOSFET is connected to each other, and it is connected to the ground. Means source and the substrate both are at the zero potential, both are at the ground potential. Okay, next, gate is also connected to the ground. It means gate it is also at some zero potential, and drain is connected with some positive potential. Okay, so this is the this is the upper side of the battery, it is the positive side of the battery, this is the negative side of the battery. So due to this battery, one electric field will develop from the positive side to the negative side. It means the electric field will develop in this downward direction, right? Due to the presence of this electric field in the downward direction, electrons will travel in the upward direction from the source to the drain, like in this direction. ठीक है। इलेक्ट्रॉन का मोशन अपवर्ड डायरेक्शन में होगा एंड एज अ रिजल्ट अ करंट दैट इज द ड्रेन करंट इट इज स्टार्ट फ्लोइंग, a drain current starts flowing from drain terminal to the source terminal. All right, so we will draw one plot. So we will draw one characteristics plot, the graph between drain current ID versus drain to source potential VDS. Okay, so in this circuit when in this circuit this source it is connected to the substrate, it is at the zero potential, source it is at the zero potential, gate is also at the zero potential. So the potential difference between the gate and the source, it is zero. So first we will plot a characteristics plot for VGS is equals to 0. So when VGS equals to 0, VDS is also equals to 0. When VGS, in this case VGS is equals to 0, अगर VDS भी हमारा 0 होगा तो सर्किट में कोई इलेक्ट्रिक फील्ड डेवलप नहीं होगा, कोई मोशन ऑफ द चार्ज कैरियर नहीं होगा. In this case when VDS is equals to 0, ID is also equals to 0. Right? Now when we increase the value of VDS, when we apply some positive value to the VDS, electric field will develop in the downward direction. As a result, electron will start flowing from the source terminal to the drain terminal, and as a result drain current is flowing from the drain terminal to the source terminal. So जैसे जैसे हम लोग VDS राइज करेंगे, सर्किट में एक करंट, ड्रेन करंट फ्लो करना शुरू करेगा फ्रॉम ड्रेन टर्मिनल to the source terminal. So when VDS equals to 0, current is also equals to 0. Now if we increase VDS, our drain current will also increase. It will reach to the maximum capacity of the channel. ठीक है, it will reach the maximum capacity of the channel, and after that this current becomes constant. Now फर्स्ट केस में हमने कंसीडर किया था गेट जीरो पोटेंशियल पर है. अगर गेट में जीरो पोटेंशियल ना देके हम कोई पॉजिटिव वैल्यू अप्लाई कर दें, लेट सपोज वी आर अप्लाइंग +2 वोल्ट. सो ड्यू टू दिस +2 वोल्ट, दिस विल बी पॉजिटिवली चार्ज्ड, एंड सिंस दिस plate it is positively charged, so it will attract electrons from this p-type substrate, and as a result this channel thickness will increase. So जब हम गेट में कोई पॉजिटिव पोटेंशियल अप्लाई कर रहे हैं, ड्यू टू द पॉजिटिव पोटेंशियल अक्रॉस द गेट, this gate terminal will attract minority charge carrier, that is the electrons from the p-type substrate, and as a result this channel thickness will increase, and hence the current carrying capacity of this channel will increase. So जब गेट में हम कोई पॉजिटिव पोटेंशियल अप्लाई कर रहे हैं, सोर्स हमारा जीरो है, it means the VGS becomes positive. In the previous case both gate and the source are at ground potential. In the previous case, both gate and the source are at the ground potential. So VGS is equals to 0. VGS stand for VG minus VS. So in the previous case, VG is also equals to 0. VS is also equals to 0. So VGS equals to 0. So we obtain this plot. Now in the second case, we are applying some positive potential across the gate, and the source it is at the zero potential. So VGS is now becomes positive. सो जब हम VGS को पॉजिटिव अप्लाई करते हैं तो हमारा पॉजिटिव चार्ज के कारण माइनॉरिटी चार्ज कैरियर, दैट इज इलेक्ट्रॉन फ्रॉम द p-type substrate, इट इज अट्रैक्टिंग टुवर्ड्स दिस चैनल, एंड एज अ रिजल्ट द चैनल थिकनेस विल इंक्रीज, and hence the current carrying capacity of this MOSFET will increase. So जब VGS इक्वल टू 0 का अगर ये प्लॉट है, अगर हम इसमें कोई पॉजिटिव पोटेंशियल गेट पे अप्लाई कर देते हैं तो डिवाइस की करंट कैरिंग कैपेसिटी में राइज होता है. सो लेट सपोज दिस इज द प्लॉट ऑफ VGS इक्वल टू +2 volt. If we further increase the gate potential, this curve will move further higher and higher. So let's suppose this is VGS equals to +3 volt. Now what will happen if we apply some negative potential? अगर हम गेट में नेगेटिव पोटेंशियल कुछ अप्लाई कर देंगे, लेट सपोज गेट में हमने -2 वोल्ट अप्लाई कर दिया. सो ड्यू टू दिस -2 वोल्ट, दिस प्लेट, दिस मेटलिक प्लेट विल बी नेगेटिवली चार्ज, and due to this negatively charge, the electrons from this n channel will repel towards the substrate, and as a result the channel thickness will decrease, and if the channel thickness will decrease, it will reduce the current carrying capacity of the device. So if VGS is equals to negative, it will reduce the current carrying capacity of the device. Let's suppose this is for the -2. If we further increase the negative potential across the gate terminal, this current capacity will further go down. So this is the characteristics of depletion type MOSFET. This is ID versus VDS at different values of VGS. So this characteristics, it is called as the output characteristics. Next important characteristics of depletion type MOSFET, it is the relationship between ID and VGS. So the relationship between ID and VGS is given by the mathematical equation ID is equals to IDSS 1 minus VGS by VP whole square. Where ID is the drain current, IDSS is the maximum drain current, VGS, it is the potential difference between the gate and the source terminal, VP stands for the pinch off voltage, and this mathematical relation, it is called as the Shockley equation. This equation, it is called as the Shockley equation. ओके. नेक्स्ट एग्जाम में ट्रांसफर कैरेक्टरिस्टिक स्केच करने के लिए क्वेश्चंस कई बार आते हैं, तो एक क्वेश्चंस मैं यहाँ डिस्कस करूंगा। स्केच द ट्रांसफर कैरेक्टरिस्टिक्स for an n-channel depletion type MOSFET with IDSS is equals to 10 milliampere and VP equals to -4 volt। तो सबसे पहले सेम प्रोसीजर फॉलो करेंगे। सबसे पहले हम इक्वेशन लिखेंगे, शॉकली इक्वेशन लिखेंगे। ID इज इक्वल्स टू IDSS 1 minus VGS by VP whole square। Next we will substitute the value of this IDSS and VP. So IDSS is 10 milliampere. 10 milliampere in terms of ampere, it is 10 into 10 to the power minus 3 multiplied with 1 minus VGS by VP. VP here it is -4. So bracket close. So on simplification I can write it is 10 into 10 to the power minus 3 1 plus VGS by 4 whole square. Next we will take some points. VGS, this one is ID. So here I have taken some coordinate. VGS equals to 0, -1, -2, -3, -4 and +1. You can take other point -0.5, -1.5, -2.5, +0.5, +1.5 and so on. So first for VGS equals to 0, in this equation if you substitute VGS equals to 0, ID become equals to 10 milliampere. If we substitute VGS equals to -1, so 1 minus 1 by 4, it is 3 by 4, square of it is 9 by 16. So on simplification it will give you 5.625 milliampere. Next, if we substitute -2 here, so 1 minus 2 by 4, 2 by 4 is half, 1 minus half is half, square of it is 1 by 4. So 10 divided by 1 by 4, it becomes 2.5 milliampere. -2 by 4 half. Okay, for -3 it is 1 minus 3 by 4, so it becomes 1 by 4, square of it becomes 1 by 16. 10 divided by 16, it is 0.625 milliampere. For -4 here, 1 minus 1 is 0, so ID becomes equals to 0. +1, it is 1 plus 1 by 4, it is 5 by 4, square of it is 25 by 16. So ultimately the result becomes 25 by 16, it becomes 15.625 milliampere. 15.625 milliampere. So here I have taken, on y-axis I have taken ID, the unit here I have mentioned it is milliampere. On x-axis it is VGS, the unit I have mentioned here it is volt. So when VGS equals to 0, ID is equals to 10 milliampere, representing this point. When VGS equals to -1, it is 5.625. VGS equals to -1, it is 5.625, somewhere around this point. Next, when VGS equals to -2, it is 2.5. 2.5 is the half of this. When VGS equals to -2, it is 2.5. When VGS equals to -3, it is 0.625. 0.625 is somewhere here. And finally, when VGS equals to -4, ID is equals to 0. So this is that 0 point. When VGS is equals to +1, ID is equals to 15.625 milliampere. So when VGS equals to 1, 15.625 representing somewhere this point. Now by connecting all these points, we can draw the transfer characteristics. So this line, it represents the transfer characteristics. This represents the transfer characteristics of depletion type MOSFET. Depletion type MOSFET. More specifically, in question it was given n-channel depletion type MOSFET with the specification IDSS is equals to 10 milliampere and pinch off voltage Vp is equals to -4 volt.